Today's lesson, advanced functions lesson, is on 5.4, solving rational equations. So get yourself in the right mindset here, because we're putting together two things that students sometimes struggle with. One is word problems and two is fractions. Okay, let's get started. Example 1, solve for x algebraically. So this first slide isn't word problems. Our next one will be. Verify with graphing technology, what do you expect to see? So what we expect to see is, for this example here, is a point of intersection. Anytime you're solving, you're looking for where one side balances with the other side. First thing we have to do is look for restrictions before we can do anything. We have to state our restrictions. So x cannot equal the first rational expression gives us x cannot equal -4. The second one, so we can maybe tell what it is by looking at it, but if we factor, then it might be a little easier to see. So I'm just going to factor the second denominator for x plus 1. So I can see my other restriction is -1. Those are my two restrictions. Now, how do we solve fractions? How do we solve for x in rational expressions? So what we have to do is, for this one, we can cross multiply. Anytime you have one fraction on one side, even though there's a binomial here, this is one piece because there's one operation of division here. So when you have one fraction equals one fraction, even though it's kind of messy, when you have one fraction equals one fraction, then you can cross multiply. Cross multiplying means we take one denominator and we multiply it up and across with the other numerator. And same thing on this side here. So let me just start with this side here. 10 times 4 times x plus 1. So I'll just take the 10 and the 4, and we've got a 40 with those two, times x plus 1. That is all on the left side. Now my equal sign stays where it was, right in the middle. And now I'm going to cross multiply this up, this binomial up with the 15. So that's going to be 15 times x plus 4. I have no fractions left now because of cross multiplying. You can only cross multiply when you have one fraction equals one fraction. If you look over to example B, we're not going to be able to cross multiply there, because it's not set up like that. Okay, back to our question. Let's distribute the 40 in, and we get 40x plus 40 equals 15x plus 60. Next step is to collect like terms. I'm going to put my x's together on the left-hand side. That will give me 25 x's, and my constants on the right-hand side is 20. So I get x equals 20 over 25, but we're going to reduce that always. That's 4/5. So back up to the question that I had originally in the instructions. So we solved it. We got x to be 4/5. And I'm going to show you that with graphing technology here. So the red one is the left side. The blue graph is the right side. And their point of intersection right there is this coordinate right here. That's a point of intersection. That's our 4/5. So those two graphs, the left rational and the right rational, are equal to each other when we found our solution. When x is 4/5, that's where they cross, and that's the only place they will cross. So it's hard to tell. Maybe here you might think, oh, maybe they're going to cross again, but they're not. If they were going to cross again anywhere else, we've got more than one answer here. Let's try part B. Okay, part B, as I was saying, is, so this, on this side, this is like a proportion. A fraction equals a fraction, we can cross multiply. Here I've got one fraction, a plus sign, another fraction, so I can't cross multiply. On the right side, this is just one piece. I could cross multiply if I had one piece over here, but this plus sign is separating this big line from being all over one, so I can't cross multiply. And there are a couple of different strategies here. The one strategy I'm going to show you here is to find a common denominator. So common denominator, this is a good review for us. Our first step always, I'll put some steps over here. Our first step is going to be to factor. If we can factor anything, let's factor. We can take a greatest common factor out of our first denominator. Actually, let me change colors here so that there we go. Our first denominator factors into x times x minus 2. And does anything else factor? Take a look. No. So that's all done. There's our first step, is to factor. Our second step that we're going to do is to state restrictions. And what are our restrictions? Our restrictions are whatever our denominator, whatever would turn our denominator into 0, which we can't have. So our restrictions, we have x cannot equal the monomial, the first one right here that I'm underlining, x cannot equal 0. The second one, x cannot equal 2. This is another 0, so I don't need to write it again. And this is another 2, so I don't need to write it again. So those are all of our restrictions right there. Our next step is to determine the lowest common denominator and multiply each term by it. So each term, I just underline that. So this is one term, this is a second term, and there's our third term. So let's find the lowest common denominator. The lowest common denominator, you can review this from earlier chapters, but the lowest common denominator in this case would be an x and x minus 2, a monomial and a binomial. So I'm going to multiply each term by that. What I'm going to do, let me write that here. My lowest common denominator, I'll put it here. My lowest common denominator is x times x minus 2. So I'm going to rewrite what I had in blue there, and I'm just going to space it out a bit so I can leave room to show you this long kind of step here of multiplication of my lowest common denominator. So I just rewrote the question that's in blue, but now I'm going to put my lowest common denominator in. So this piece right here, my first term, I'm going to take that and I'm going to multiply it by x and x minus 2. The second term, that's why I left that gap there, because I want to fit this in here. I'm going to multiply that by x times x minus 2. And my last piece as well, I'm going to write it to the right of it. I'm going to multiply it by x times x minus 2. So remember this x times x minus 2, this is all, each one, it's all over an invisible 1. It's not over x times x minus 2. It's a common mistake with fractions to think that whatever your numerator is, your denominator is as well. Students think 2 is the same as 2 over 2. Of course it isn't. So what we're going to do here, the reason this method, I like this method, is it gets rid of the denominators. So this monomial x will cancel out with this monomial x. This binomial x minus 2 will cancel with this binomial x minus 2, and I'm left with 10 plus, next set here, this term just has a denominator of a single x, so that cancels out. So I still have these two things to multiply together. I still have 4 times x minus 2, so I'll write that out here. I've got 4 times x minus 2. I still have to do that. Now my last piece, I have a denominator of x minus 2, which cancels with the x minus 2, so I still have this x here with this 5. So I still have to do 5 times x, which is just 5x. So we clean that up and we get 10 plus 4x minus 8 equals 5x. And now we're back to grade 10. You could, grade 9, you could solve that in grade 9, maybe even grade 8 if some of your grade 8 teachers did that with you. So this is not new now. Everybody's able to collect all of this stuff together. I'm going to put all of my x's on the right and I'm going to get a single x, and then I'm left with 10 minus 8 over here, 2. So x is 2. So I don't have a graph to show you this here. We're not quite done. So this would indicate that x equals 2 is the solution. It's the point of intersection. But I'm going to go to my rarely used highlighter here. Look up here at the restrictions. 2 is a restriction. So the algebra we're doing, the algebra doesn't know that there was a restriction. Once we converted all of this to one line, as we did right here, we put everything in one line right there. As soon as we did that, there was no more restrictions. There's no more considerations about what x can or cannot be. We just did the algebra and we got a 2 for an answer. So we have to remember that our original question did have fractions and it did have denominators and there were restrictions. So x equals 2 is an invalid or an extraneous solution because of the restriction. There are actually no solutions to this question. If you put this one into Desmos, you'll see what I mean. If you the original, right? You would always put the original into Desmos here. So you put this side in as one equation and then this one in as another. So what we get here is no solution. Because of the asymptote, they're actually not going to cross because there's an asymptote there. So we won't have any solution because of the restriction. Okay, now that we reviewed how to work with fractions, let's get to the word problems. Example 2. Brittany in Jazzway paint home interiors on the weekend to save money for university. Okay, I'm reading one sentence at a time, and that first sentence, I don't really care. There's nothing really important in there, so I'm going to ignore that. Next sentence. Brittany can paint a room in 4 hours. Okay, sounds good. Imagine that. Imagine the room you're sitting in, you paint it in 4 hours. Great. Jazzway can paint that same room in 6 hours. So she's much more careful than Brittany. She takes a little longer, it takes her 6 hours. How long would it take both Brittany and Jazzway to paint a room if they are working together? Now, the most simplest thing that you might think to do is just say, oh, they're working together. Let's add 4 plus 6. 10 hours. It's going to take them 10 hours. No way. Look, think about that for a second. If Brittany alone can paint it in 4 hours, then if she's working with somebody, how could it possibly take them together 10 hours? So we have to think more about what's going on in this question. It should take less. If Brittany can paint it by herself in 4 hours, and if Jazzway starts helping, I'm expecting the answer to be less than 4. So don't just jump to addition here. So let's get some points to look at here. What will the independent variable be? There's 2 considerations: how much time and how many rooms, portion of rooms. Those are our 2 variables. Well, they're not necessarily variables, but those are the 2 things we're talking about in this question. What do you think? T, yeah. Usually when you have time, it's going to be your independent. So we'll use T to represent time in hours. Now, a really important part of all our word problems today is we're talking about rates. Everything is something per something. This question is painting a room in a certain amount of time, so everything is a rate. So what is the rate here? The rate is, what we're looking for is how many rooms you can paint per hour. This is the reverse of the rate we're given in the question. That's why it's a little harder. They told us hours per room, right? It said Brittany can paint 4 hours per 1 room, but we need our independent variable to be last. We need it to be rooms per hour, not hours per room. I don't know if you're following that or not. So let me just go over that again. Brittany can paint in 4 hours, she can paint 1 room. I don't want to know how long it takes her to paint 1 room. I want to know how much she can get done in an hour. So her rate is 1/4 of the room per hour. If it takes her 4 hours to do 1 room and I only give her an hour, I'm only going to give Brittany 1 hour to paint this room, she's only going to get 1/4 of it done because it should take her 4 hours. Think of 1 hour per wall maybe. I give her 1 hour, she's only going to get 1/4 of the room done. So this is the rate that I want here, per hour. That's Brittany's. So what do you think Jazzway's is? If she can paint a room in 6 hours, then what I really want to know is how much of the room can she get done in 1 hour? If I only give Jazzway 1 hour, how much of the room is she going to get done? 1/6 of the room she's going to get done per hour. So I'll think about this. If they work together for 1 hour, how much of the room would they paint? So this is where you don't just add it up and say 4 plus 6. If they work together for 1 hour, so Brittany's going to get 1/4 of the room done in an hour. Jazzway's starting at the other end of the room. She's getting 1/6 of the room done in an hour. So if they had 1 hour to paint, we would be adding these numbers here. And what if they had 2 hours? Well, if they had 2 hours, Brittany would be getting a quarter of the room and another quarter of the room. She'd get half of the room done. Jasway would get a sixth of the room and another sixth of the room done. That's 2/6 or a third. So we're going to come up with we're working towards an equation here. So think about how we can put all of this together. We're looking for how long it can take them to do one room. That's the question, right? How long will it take them to paint a room if they're working together? So working together, we've got Brittany takes her rate is 1/4 of the room per hour. And we're letting t represent per hour. So if she has 1 hour, she's going to have 1/4 times 1 hour. If she's got 2 hours, you're going to put a 2 in there, 3 hours, and so on. So that's her expression. Jasway is 1/6 of a room times however many hours we give her. Right, if we give her 2 hours, we times by 2. And when they're working together like that, this last piece is a constant. It's got to equal 1 because we just want one room. It's not a variable, one room. So here's our equation. Now we can go back to our previous examples. The one thing I'm going to do is just clean it up. Instead of the t being off to the side, I'm going to put it in the numerator, t over 4, or you could write 1t if you want, 1t over 6 equals 1. So I can't cross multiply because I don't have a fraction equals a fraction. I have a fraction here, another fraction here, and then this number. So I can't do cross multiplication. I'm going to multiply by the lowest common denominator. The lowest common denominator is a 12. So I'm going to multiply this by 12. I'm going to multiply this term by a 12. Every piece gets to 12. So 12 and 4 reduce to a 3. So I have 3t here. 12 and 6 reduce to 2. That's 2t. And then 12. We had no restrictions to worry about because we didn't have unknowns in our denominator for this question. So there's a nice little equation. We get 5t equals 12, or t equals 12 over 5. So 12 over 5, we're just going to convert that. 12 over 5 is the same as 2 wholes and 2/5. But you wouldn't, if you're painting somebody's house, you wouldn't say it's going to take me 2 2/5 of an hour. Or it's going to take us together 2 2/5 of an hour. So 2 over 5, of course, is the same as 4 over 10, so it's 0.4. So so that's 2.4. So we're going to have a sentence. Therefore, always with a word problem, we need a sentence. It will take them 2.4 hours to paint the entire room. And there we have it. We have a question later where we're actually, instead of doing 2.4 hours, we're going to do 2 hours and how many minutes. So I'll go over that later. Next example, Enoch flies to California and then rents a car to drive back to Ajax. He knows that a plane can fly 1,600 miles in the same time it takes a car to drive 310 miles. So just think about that. A plane, of course, can go a lot further in the same amount of time as a car can. 1 mile is 1.6 kilometers. But this whole question is based on, as you have in your homework, some questions that are in imperial. So we're going to stick with miles here. If Enoch's car travels 258 miles per hour slower than the plane, what is the speed of the plane? What will the independent variable be? And this time we've got time and speed, not distance. Distance is a constant. So what do you think the independent will be? It's going to be time. And what's our rate? Our rate is miles per hour, and we didn't have to figure that out. It was already in the question, mph, miles per hour. So I'm going to review a method that you learned way back in grade 10. You use this chart method a lot when you had something like you're canoeing upriver, and then when you're downriver against the current, or you had plane questions where you were in a tailwind or a headwind, and lots of questions like these in grade 10. So I'm just going to review this method with you. And very common for distance, speed, time to use a chart. And remember this formula, distance is equal to speed times time. So here is the chart. Let's fill in some values here. So we already said that T is going to be time in hours. So I'm going to put a T here and here. I don't know for either of these. These are both T. Now, what do we know about distance? So the distance was given to us in the question that a plane can fly 1,600 miles in the same time. So that's why I have my T here, the same both places. This is the car, 310. So what I have here is the plane in this amount of time, just T, that same amount of time here, the car can go 310 miles. So that's all I have so far. Now what about speed? So looking up at the question, the only information I have about speed is right here. Enoch travels 258 miles per hour, sorry, the car, slower than the plane. So I don't really, I'm gonna have to bring another variable in here. So I don't want to use S because S looks like a 5, so let's use R for rate. So the speed of the plane, we'll call that R. That means the car is slower than that, 258 miles per hour slower than that. So we have a lot of variables here with this chart method, but that's okay. Let's look at this. So I'm going to set my equation is distance equals speed times time. I have two equations here. The plane equation, let me do that one first. That plane equation is 1,600 equals R times T. Then I've also got a second equation for the car. So you see how we're back in grade 10 here? Maybe you remember what's going to happen next. 310 equals R minus 258 times T. So we have, there's a couple of ways to do equations like this. For this one, I think I would use substitution. I'm going to isolate T. So I'm going to isolate T. Let me switch colors here. I'm going to isolate T here in equation 1. And then once I isolate T, I'm going to sub it into equation 2's T. So isolate T, I'm going to divide both sides by R. And these R's cancel out. And I have 1,600 over R equals T. So I'm going to take that T, this is T, here's another T here. I'm going to switch out these T's. I'm going to take this T out, and in its place, I'm going to put this T here. So my equation 2 is now 310 equals R minus 258. And instead of that T, I'm putting 1,600 over R. Okay, so there's a couple of different ways to do this. I could have also isolated T in equation 2 and then made those two equations equal to each other. I could have done that as well, but we're going to get the same thing here. So I have one equation now. I've put equation 1 and 2 together. I've used the method of substitution here. And now I can actually cross multiply because I have a fraction equals a fraction. Let me just explain that. This piece right here, this whole right hand side, because they're being multiplied together, it's all one term. So if I take that entire side and multiply it by R, these R's will cancel. And I'm going to multiply. I have to do the same to the other side, so I'm going to multiply the left side by R. And when I do that, I get 310R equals R minus 258 times 1,600. So if that method that I just did there was a little bit that kind of threw you off, you can go You can go back to one of the other methods. You can distribute everything first and collect like terms and then get a lowest common denominator, but yeah, this is advanced functions, so we should be able to pick up a new strategy here. This understanding that this piece here is all one term is kind of key right here. By seeing that this side is all one because it's being multiplied together, then that allows me to just multiply by the lowest common denominator, which is an r. Okay, let's get back on track here. We get 310r equals, and I distribute over here, 1,600r minus 412,800. I think that's right. Okay. Collect like terms. I'm kind of running out of room here. I'm going to jump to the answer. I get r equals 320. So what does that mean? Go back to your chart. What did r represent? What does r stand for? So here's our r. R represents the plane's speed, right? R represents the speed of the plane. So therefore, the speed of the plane is 320 miles per hour. And oh, that's all we had to do. I'm just looking up at the question up here at the top here. What is the speed of the plane? I didn't have to do anything else. I kind of was expecting to have to sub this r back into something over here, but I don't. This is all I have to determine. Therefore, the plane's speed is 320 miles per hour. And remember that Enoch's car was 258 miles per hour slower than that. Does that make sense then for a car speed? Yeah, an Imperial, the 62 miles per hour is an average speed. So that's using the chart method to solve the problem, which kind of works when you have two different things, plane and a car going two different speeds. Works well for that kind of question. Example 4. This is a tricky one. I'm going to start at the bottom here. We're just going to create an equation for this question because you have it assigned in your homework, number 11, so we're not going to do the whole question here. Okay, Courtney purchased a large box of comic books for $300, right? So you've got a visual for that. You understand what that first sentence means? Good, then we move on. She gave 15 of the comic books to her brother. Okay, so we're good here. We don't know how many were in the box, but she gave 15 away. And she sold the rest on an internet website for $330, making a profit of $1.50 on each one. How many comic books were in the box? And what was the original price that Courtney paid for each comic book? Okay, this is a little more complicated than the other one. What will the independent variable be? So we're talking about price and number of comic books. What do you think would be independent there? We're going to say the number of comic books is independent. So X is going to represent the number of comic books in the box, and the rate this time is price per book. We're trying to figure out the price per book. The question said that, right? What was the original price that Courtney paid for each comic book? Think about this. If there were 50 comic books originally in the box, what was the price that Courtney paid? So let's just look at the original question here. She paid $300 for a box of comic books. If there were 50 in there, how much did she pay per book? So that would be $6. $6 times 50 books is 300. So think about the math. That's what I always do when I don't know how to do a question. I throw some numbers in for myself and I try to actually calculate the math. What am I doing here? Adding, subtracting, multiplying, dividing. So I throw in a number. If there were 50 comic books in the box, okay, now I know what I'm doing here. I would be dividing that. So that helps me to see an expression for the original price of her book. So what you guys did too in your head there, was you took your 300 and you divided by 50. But we don't know 50. We know X. So this is an expression for the original price per book. $300 divided by however many books were there. We don't know. It wasn't 50. We don't know. So she gave 15 away. So how many books are in the box now? Just how many books are in the box if she gave 15 away? X minus 15. We also know she resells them online for $330. What's the price per book now? So I want you to think about this before I show you the answer. What's the price per book now? This was our original price per book. What's the price per book now? So 330 over, she has 15 fewer of them. So it's not over X, it's over X minus 15. So I put those two previous expressions together to get our price per book now. Now, Courtney makes a profit of $1.50 per comic book. We have a lot of per comic book things here. Here's a per book, right? Here's per book. Here's per book. So we can use all of this to put them into an equation. Her profit, you know what profit means. Her profit is equal to the lower cost subtracted from the higher cost. So you take whatever your more expensive was, subtract the cheaper, you should be left with $1.50. That's your profit. So you just have to decide between these two right here, which one is the greater number. So we're taking, this is what she resells for, and she's making a profit. So what she's ever reselling for has got to be worth more. This is what she's reselling for. This is what she paid originally, and she's ending up with $1.50. That number there is a constant, right? Because that's per book. That's per one. You can put per one if you want to, but that's for one book, $1.50 for one book. So that's all I'm going to show you for that question, because you do have to finish it in the homework. And if you're not in my class, you can certainly go ahead and finish the question right there and work on it to see if you can do you've got different methods for working with this one. This one maybe would be a good time to do the common denominator one, multiply everything by x times x minus 15, get rid of these fractions, and solve it. One more example. Tina and Orion work at a shipping warehouse. Okay, that's fine, but I'm going to ignore that now. Tina can fill an order in S minutes. So I'm going to skip to the bottom. This is another one that I took out of the homework, and they use S. I don't like S. It looks like 5, but they use S. So we're going to stick with S. Orion can fill an order in S minus 2 minutes. When Tina and Orion work together, they can take about 1 minute and 20 seconds to fill an order. This is similar to the paint question, right? Painting a room with Jazway and Brittany. How long does it take each person to fill an order? Create an equation only, but do not solve, because you'll do that in your homework. This is number 13. And when you get to the homework question, there's a whole other person in there. It's like, I can't remember, it's Christian or somebody. There's a third person. I actually changed all the names, but there's 3 people in the textbook, so it's even harder. So we're just going to kind of get a start on it here. I'm giving you the rate that we're going to use as orders per minute. Okay, let's throw some kind of real numbers in here. Try to make sense of this with some real numbers. Think about it this way. If Tina filled 1 order in 3 minutes, here it says she can fill an order in S minutes. Let's say she can fill an order in 3 minutes. How much of an order could she fill in 1 minute? So she's working at the Amazon warehouse and she's packing boxes. She can pack a box in 3 minutes, but I only give her 1 minute. How much is she going to get done if I only give her 1 minute? How much of that order is she going to get packaged? So we have to rearrange again. The question is giving us the answer. The question is giving us the information in kind of the wrong order that we want it. So if she can fill an order in 3 minutes and I just give her 1 minute, what's her rate? She would get 1/3 of an order done in a minute. That's how much she would get done in a minute. Okay, so putting that 3 in kind of helps me to make sense of the S here. So she can fill 1/S of an order in 1 minute. That's 1 order gets done in S minutes. That's how we're writing that out. 1 order done in S minutes. 1/S. 1 per S. Orion is 1 over s minus 2 because he can fill one order in s minus 2 minutes. So this is where we get a fraction. There were no fractions anywhere in this question, right? Or in any of them, there's no fractions, but we have to introduce the fractions because we have to get our rates set up properly. Now, what about them working together? When Tina and Orion work together. So let's talk about that. When Tina and Orion fill an order in 1 minute and 20 seconds, the first thing I want to do is get rid of the seconds part. We need this to be in minutes. 1 minute and 20 seconds. So that's 1 minute and 20 out of 60 seconds. That's 1 1/3, which is 4/3 minutes. So let's just to get everything in minutes here instead of this minutes and seconds stuff. So 4 over 3 minutes is how long they take to do an order together. So their rate is 1 over 4/3. 1 over 4 over 3. We're going to fix that fraction in a minute here. Now we need an equation. So let's look at this sentence here from the question. When Tina and Orion work together, they can take about 1 minute and 20 seconds to fill an order. So how do I put this into an equation? When they work together. Okay, when they work together. So I'm going to put a circle up here. This is Tina's rate. This is Orion's rate. And when they work together, this is the constant here. This is what they're getting done. So my equation is 1 over s plus 1 over s minus 2. That's going to equal 1 over 4/3. Now I'm going to fix that there, that 1 over 4/3. We don't like in math to have all those levels of fractions. So let me just put an aside over here. 1 divided by 4/3 is the same as 1 times, invert and multiply, 3 over 4. So that's 3 over 4. So I'm going to change that to 3 over 4. 1 over s plus 1 over s minus 2 is equal to 3 over 4. So now to finish the question, it's similar setup to the one that we just did with the comic books. You find your common denominator, which is going to be s times s minus 2 times 4. We've got 3 denominators here. You put them all together, common denominator, multiply each piece by that. That's one way to do it. There are other ways to do it, and you can watch other videos on other ways to add fractions. One is to just determine the common denominator and solve it from there. So that's one way to do the question, is to multiply by a common denominator to get rid of all the fractions. So that's another question that you can finish on your own if you have your textbook. If not, you can just continue working on that here and solve this question on how long it takes them to fill their orders. That's the end of this complex lesson, putting together fractions and word problems. Every teenager's favorite thing to do. Good luck, you guys.